Students, in this session we are going to see magnetic properties. First of all, we see what are the magnetic properties. So you see, all the substances are not magnetic. Further, all the magnetic substance will not behave in the same manner. So, magnetic properties help us to classify the magnetic materials into different groups. So in this session we are going to see what are the magnetic properties. First one is the magnetizing field. Magnetizing field. So what is called magnetizing field? This magnetizing field is represented by H. A magnetic material gets magnetized when it is kept in the external magnetic field. So this external field, which is used to magnify or magnetize a magnetic material, is called as magnetizing field. So the external magnetic field, which is used to magnetize a magnetic material, is called as magnetizing field. It is represented as H and its unit is ampere per meter. The second magnetic property is the permeability. What is called permeability? And it is represented by mu. Permeability measures the ability of a magnetic material to allow magnetic field lines to pass through it. So you consider a cardboard. You keep iron filings above the cardboard. You keep the magnet below it. Then as you move the magnet, the iron filings will move along with the magnet on the surface of the cardboard. How it is possible? The cardboard is allowing magnetic field lines to pass through it. When I do the same experiment with the wood, so take a wooden board, you spread iron filings over the wooden board, keep a magnet. The iron filings will not move as I move the magnet. It means the permeability of wood is zero. It is not allowing any magnetic field lines to pass through it. So, permeability measures the capacity of a magnetic material to allow magnetic field lines to pass through it. So, permeability of free space or vacuum is represented by mu naught. And permeability of free space or vacuum is represented mu naught. This is permeability of vacuum or free space. Permeability of a medium is represented by mu. This is permeability of a medium. So it is always greater than 1. It takes the value always greater than 1. And its unit is Henry per meter. Henry per meter. Mu r is called the relative permeability. Relative permeability of a medium. It has no unit and it is given by mu r is equal to mu by mu naught. So relative permeability of a medium is equal to the ratio of the permeability of medium to the permeability of vacuum or free space for air. For air, mu r takes the value 1. So this is called as permeability. The third property, magnetic material property, is intensity of magnetization. Intensity of magnetization. Intensity of magnetization is given by modulus of n vector. This is equal to magnetic moment per unit volume. So when you consider a magnetic material, it is made up of atoms. In that atoms, electrons are revolving around the nucleus. Due to the orbital motion of the electron, it produces orbital magnetic moment. This orbital magnetic moment produced is perpendicular to the plane of the orbit. Since electrons are randomly oriented, so the orbits are in random manner. So the induced magnetic moment is oriented randomly. So the resultant magnetic moment is the vector sum of all magnetic moment produced by the revolving electron, which is equal to 0. When such magnetic material is kept in external magnetic field, magnetic moment is induced. This induced magnetic moment per unit volume is called intensity of magnetization, and its unit is ampere meter. When you consider a bar magnet, so when I consider a bar magnet, this bar magnet is having area of cross section A, length to L. Therefore, magnetic moment of the bar magnet is given by volume is equal to magnetic moment is given by Q M into 2L, magnetic moment, and volume is 2L into A. This 2L and 2L gets cancelled. So for a bar magnet, intensity of magnetization is equal to Qm by A. So Qm is measured in ampere meter. Area is measured in meter square. So ampere per meter is the unit for intensity of magnetization. Then fourth one is the magnetic induction. Magnetic induction. Magnetic induction is also called as total magnetic field. Total magnetic field. So total magnetic field B is equal to sum of the magnetic field produced in air or vacuum by the external magnetic field plus the induced magnetic field inside the specimen. So this B naught is given by mu naught into H plus mu into H. So you will have H is taken common, you will have mu naught plus mu. So this is the total magnetic field. So total magnetic field is nothing but magnetic induction. So when a magnetic material is kept in external magnetic field, the total magnetic field produced in that material is equal to sum of the magnetic field produced in vacuum due to the external field and the induced magnetic moment inside the specimen. So it is equal to B naught plus Bm, which is equal to mu naught H plus mu H. So H is taken commonly outside, mu naught plus mu. This is the total magnetic field. The next property is the magnetic susceptibility. It is represented by chi m. This is chi m. Magnetic susceptibility is given by the formula chi m is equal to intensity of magnetization by magnetizing field. So this measures the magnetic susceptibility. Magnetic susceptibility is the ratio of intensity of magnetization to the magnetizing field. So these are the 5 properties of magnetic material. Based on this magnetic properties, we can classify magnetic materials into different types. So first one is the magnetizing field, second one is the magnetic permeability, third one is the intensity of magnetization, fourth one is the magnetic induction, and fifth one is the magnetic susceptibility. So these are the 5 properties of magnetic material. Next we are going to see how to classify magnetic material based on this magnetic properties. Based on the magnetic properties, magnetic materials are classified as diamagnetic material, paramagnetic material and ferromagnetic material. So in the next session we are going to see what is diamagnetic material and what are the properties of that diamagnetic material. Secondly, we are going to see what is paramagnetic material, what are its properties, and finally we are going to see what are ferromagnetic materials and what are the properties of it.